There is a specific sensory experience to dragging a knife through a thick, dense paste and watching it glide across a piece of fresh bread. Hazelnuts provide the primary flavor profile for this breakfast staple, necessitating a manufacturing operation of global proportions. This single product consumes a significant percentage of the entire worldwide supply of raw hazelnuts. Transforming millions of hard, irregular nuts into an identical, silky paste requires a series of mechanical steps. To see how those raw crops are broken down and rebuilt, we have to leave the kitchen and walk the floor of a heavily automated processing plant. Achieving this uniformity means taking an organic crop and forcing it through a series of planned physical and chemical changes. The process begins in the field. Cultivators gather raw, mature hazelnuts by hand, harvesting the organic material that serves as the base ingredient. Once harvested, automated sorters strip away dirt, leaves, and cracked shells. Only intact, high-quality nuts move forward onto the factory conveyor belts. Inside the facility, the nuts drop into massive roasting ovens. Computer systems manage the exact temperature and dwell time to ensure the roasting is consistent across every batch. At this stage, the nut lacks its characteristic scent. The oils inside a raw hazelnut do not possess that distinct aroma on their own. As shown in this cross-section, the sustained heat acts as a catalyst. The temperature alters the internal structure, with molecular chains breaking and reforming to produce the specific aromatic compounds we recognize. This iconic flavor is a specific chemical state, achieved through industrial precision during the roasting process. The newly roasted nuts exit the cooling chambers and drop into heavy industrial grinders, which crush them into a dense paste with a consistency similar to chunky peanut butter. Rotating vats then fold in cocoa powder, sugar, and milk solids. If tasted now, the mixture would feel extremely coarse and gritty. To eliminate that grit, the paste enters the refining stage, a mechanical process designed to pulverize every remaining solid ingredient. Heavy machinery repeatedly mills sugar and cocoa crystals into microscopic dots, smaller than a human hair's width. The factory targets this micron size because it falls below the tongue's detection limit. Taste receptors cannot feel individual pieces, allowing the solids to glide by undetected. The creamy texture is a mechanical effect, achieved by pulverizing solids until the body lacks the ability to sense them individually. The refined mixture is pumped into large holding tanks. Heavy blades constantly stir the fluid so the dense solids and lighter oils remain integrated. Before packaging, technicians test the batch against quality baselines, verifying the color profile, flavor balance, and texture. The final pass-or-fail metric is the viscosity check, a measurement of how the thick fluid flows under pressure. Engineered without active force, the paste resists gravity, acting as a stationary block inside the jar. When a lateral force, like a knife, pushes against it, the mixture yields immediately. Its internal structure gives way, transitioning into a flowing liquid state. This ease of spreading is the result of specific, tested applications of fluid dynamics. Once a batch clears these tests, the paste is piped into filling machines, injecting the target weight into thousands of moving glass jars per hour. The production lines operate at high speeds as mechanical arms snap on seals, apply labels, and load the jars onto pallets for shipping. Trucks and container ships disperse these jars globally, placing them onto bakery counters, onto hotel buffets, and onto kitchen shelves. This product is a composite of specific agricultural and industrial steps that cannot be replicated by simply mixing cocoa and nuts. Its consistency is the result of chemical flavor engineering, high-pressure refining, and controlled fluid dynamics. The next time you take a spoonful, you're tasting the outcome of this global industrial process, captured in a single bite.